1. Two intersecting planes meet in a straight line. I have a solid figure here, and this would be our plane A and our plane B. As you can see, where do they intersect? Yes, in a straight line. So, and in at least 2 points, right? So, therefore, Theorem 1 statement is always true.
Shady girl.
Theorem 2. A plane is determined by first, a line and a point not on it. Second, two intersecting straight lines. And third, two parallel lines. To prove this theorem, I have a solid figure here. Example, given this plane and this line, this will be your point. That proves corollary 1. A plane is determined by a line and a point. Another example, I have a plane, and this will be your line 1, this will be your line 2. If we extend this, imagine they intersect at this point. So that proves corollary 2. Two intersecting straight lines. And third, a plane is determined by two parallel lines. So this will be your plane again. This will be your one line. This is your second line. They are parallel to each other. So that proves corollary 3. Two parallel lines is determined by a plane. Theorem 3. If a line is perpendicular to each of the two lines at their point of intersection, then it is perpendicular to these lines. I have a solid figure here. For example, given this plane and a line perpendicular to it and two lines, this will be your line 1, this will be your line 2. Intersect at their point of intersection, then these two lines are perpendicular to the plane also. That proves Theorem 3.
Theorem 4 states that through a point, there is one and only one plane perpendicular to a line. I have a solid figure here, and this would be our given plane, our given line, and our point. As you can imagine, if I'm going to extend this, as you can observe, there is only one line perpendicular to this plane through this point. So therefore, Theorem 4 statement is always true.
Theorem 5. Through a point, there is one and only one line perpendicular to a plane. Given an example, you have this your solid figure. This is your plane. This is your line. They meet at exactly one point. They are perpendicular to each other because we can extend these lines and also this plane. If we put another line here or here, they are not perpendicular because they are obliques. So that proves Theorem 5. Through a point, there is one and only one line
lines from a point to a plane, meeting the plane at all distances from the foot of the perpendicular are equal, and conversely, two equal oblique lines from a point to the plane meet the plane at equal distances from the foot of the perpendicular.
To prove Theorem 6 is always true, I have this solid figure, and this would be our given two oblique lines. Theorem 6 states that oblique lines from a point to a plane meet the plane at equal distances from the foot of the perpendicular. This would be our normal. And a normal is a line that is perpendicular to a plane. And this would be our foot of the perpendicular. The shortest, remember that the perpendicular is the shortest distance from a point to a plane. As you can imagine, as you can observe, that they do meet at equal distances, because Theorem 6 states that two equal oblique lines from a point to a plane meet the plane at equal distances from the foot. This would be our foot of the perpendicular. So therefore, Theorem 6 statement is always true.
난 항상 귀찮아도 매일 화장을 하고 다리가 아파도 그 높은 하이힐 신고